Welcome to Chibuzor Mathphysics. I decided to do a kind of introduction on the complex number algebra, as I found it very useful and prerequisite for us to dive into complex analysis. There are so many things that we need to know on how to manipulate the algebra that involves complex numbers. And I would like to introduce a few things in this video. Let's say that we have 3 plus 4i. In this case, a number such as 3 plus 4i is called a complex number. It is a complex number because such number have 2 terms. Each of these terms may be 0. Let's say the real term is not containing the real part not containing I. You see, I will have 3 and we have 4i. So the real part is this part that is not containing I, and this is what we call the real part. And the coefficient I is the imaginary part. Therefore, the real part of 3 plus 4i will be equals to 3. The real part is 3. The real part is 3, as we can see, and the imaginary part is 4. The imaginary part is 4, as it is indicated. So a number is real when the coefficient of I is 0, and is imaginary when the real part is also 0. We can say that, let's take for example, let's say that we have 4 plus 0i. 4 plus 0i. This is equals to 4, and this number is real because we know that anything multiplied by 0 will equal to 0. And it is imaginary if, for instance, we have 0. Let's say that we have 0 plus 4i in this case. This is real and this is imaginary, because here the solution to this would be 4i, and this is imaginary. So this is exactly what I want us to bring out very clearly, as it is a prerequisite for us in complex analysis. Having introduced a complex number now, the ways in which they can be combined. For instance, we have the addition, we have the multiplication, we have the division, and we have so many other operations that we need to be conversant with. So this term, the algebra of complex numbers, that is what we call the algebra of complex numbers. That is, they use a manipulation of addition, they use a manipulation of multiplication, and they use a manipulation of division. So let us see. Another thing that you might need to be aware of in this algebra in terms of complex number is that I squared, anywhere you see I squared, it is equal to -1. So this you have to pay attention to where it is appropriate. First, equality of a complex number must be defined. So if 2 complex numbers, let's say that we have a plus bi or c plus di. Let's say we have a plus bi, or let's say that we have c plus di. In this case, both their real and their imaginary part must be equal. So in this case, what we mean is that a plus bi is equal to c plus di. A plus bi is equal to c plus di. Of course, this will imply that a is equal to c, and it also implies that b is equal to d. So these are some of the things that we need to pay attention to as we dive into algebra of complex numbers. So let's start with addition and subtraction that involve complex numbers. Let's take addition and subtraction. Okay, we will start with an addition. Addition of a complex number is defined by separately adding real and the imaginary part. So let's say that we have z, and in this case z is equal to let's say z is equals to a plus bi, a plus bi, and then we have w, and w is equal to c plus di, is equal to c plus di. So to add these two numbers, what we need to do is z plus w. We want to add these two numbers. This is z and this is w. So add z plus w. This will be equal to a plus c. A plus c. This is a and c. Those are the real part. And now we need to add the imaginary part. The imaginary part is b plus d. Of course, we can factor out I. So we have I there. So this is exactly what we do, and it is similar to subtraction. Let's see how this works when we translate this into real numbers. So let's say that we have first example. Let's take first example to be 3 plus 5i, 3 plus 5i, and then you have plus 2 minus 3i. So we want to add these two numbers together, 3 plus 5i and then plus 2 minus 3i. So to do this, we need to first of all take the real and then we take the imaginary part separately. So this will imply that we'll have 3 plus 2, because 3 plus 2 is the real part, and then we need to add the imaginary part. And the imaginary part, as you can see, is simply 5 minus 3. Of course, you have I, 5 minus 3. This will be that we have 5. 3 plus 2 here is 5, and then 5 minus 3 is 2, but we have I, so it is plus 2i. So this is exactly how you add two numbers that involves both the real and the imaginary part. Let's take one more example on this question. Let's say that in this case we have 3. Let's say that this is question B. Let's say that we have 3 plus 5i. We have already done 3 plus 5i. Let's take 3 plus 5i. Yeah, it is okay. 3 plus 5i in this case. And then we have plus 6. We have plus 6. So we want to add these two numbers together. So the solution to this, let's take the solution to this. It will simply be the same way we did the first one. We have 3 plus 6. This will be 3 plus 6. Of course, we have 5i, so it is plus 5i. And you know what you have here, simply add this together. 3 plus 6 is 9, so this will be 9 plus 5i. It is as simple as that. And maybe we can do one more. Let's say that you are given 7. In this case, let's say you have 7i minus let's say you have 4 plus 5i. So you simply add the real or the imaginary. In this case, we have only 2 imaginary and then we have 1 real. So it is simply, let's open up this will be 7i, like we have here, minus 4 minus 5i. So this will mean that 7 minus 5 will be we have minus 4 plus 2i, because we need to arrange it. You know, we have the real part before the imaginary part. So this will be how you manipulate complex numbers in times of algebra, when we have algebra that we need to work with in times of complex numbers. And like I said earlier, this is similar to subtraction of a real number and the imaginary number